All right. Good morning, everybody. Welcome back to Comp 2452. It's the last class before the break. Hooray! Hooray! Yeah. Good. I'm really delighted about that. Yeah, and I'm also really happy that the weather is warming up and like this feel like it's it's going good. Things are happening. Yeah. Today, what I want to spend some time doing is taking a look at finishing up, I guess, what we were talking about last class. So last class, in the last like 30 seconds, I was trying to cram in this stuff at the very end. I would like to not just cram it in and actually spend a little bit of time thinking about these ideas. Then what I want to do is move on to taking a look at some of the documentation that I posted for phase 2. So the design expectations, what I'm looking for you to submit as part of your phase 2 stuff, and the kinds of expectations that you should have in terms of what you're going to be asked to do to make changes to the project that you're working on. And then what I want to finish up with today is to spend some time actually taking the SQL stuff and not just putting a REPL into our application, but like actually running SQL code from our TypeScript code. So effectively hooking up our application with the backend so we can start running, inserting, and selecting things from the database to have complex functionality and persistence here. So by the end of today's lecture, what I want you to be able to do is, we're continuing this, I want you to be able to use a programming language to interact with the database. So today, what I want you to be able to do is add things to a database and then find things based on user interactions. So we're going to run a select statement and we're going to run an insert statement based on interactions that we're doing with the user interface. Before we get to that, though, I do want to finish up this idea of how can we start to take these OO concepts, so really specifically this idea of subclasses, and start to put that into tables in our database. This idea of OO and relational databases, there's a mismatch between those two concepts in that there are things that we have in OO that are missing from relational databases, from table structures. We've addressed a couple of those problems, like we've done things like inverting the relationship between collections and the things that are inside the collection so that we can model our tables such that we can have a single column that represents the thing that owns this. We can't have arrays in our tables, but we can have single values. We're inverting that relationship so that we can have this connection between those things. The other thing that's kind of a problem here with objects and classes and OO going toward tables is this idea of I can have subclasses. I can have things that extend other classes in a type system and in OO, but I don't really have this concept of extending table definitions. There really isn't a good way to do that, especially when we want to load collections that contain subclasses or implementations of an interface. There's two options that I'm going to provide to you. This is not an exhaustive list. This is just going to be a couple of examples of approaches to solving this problem. But these are pretty typical solutions to the problem of kind of mapping these concepts of OO onto databases. The problem that we've got with OO and subclasses is that we can have different implementations, and one way to solve that is to have just one table per subclass. And that was generally okay because it meant that we can kind of stick with the convention that we've got of one table per class. So for each of the different implementations of the interface or each of the different subclasses, we just have a table. The main problem with it is loading collections of these things. If I want to know what the owning collection thing has inside of it, I then have to go through every one of the possible tables. I have to do this selection from every single table for every single implementation of this interface or every single subclass and ask that same question. So here, if I want to load all the items that a trainer has, I've got to go through every possible implementation of an item and ask the question, are there any items in this table for this trainer, even if there are none? And that's kind of actually okay. Like with the kinds of structures that we're looking at right now, we're going to have maybe 3 or 4 subclasses at most. We're not going to have 100 different subclasses in our setup. And so having to do this select star from each of those different implementations is kind of fine. Another approach, though, is to go through and take this class hierarchy and ultimately flatten that class hierarchy. So I want to take every instance variable of every subclass, and I want to merge all of those together. Make one table that has about 100 columns in it for every single property on every single subclass. This is great because it means that we can now just do one select statement. I can select and I can get every item that trainer could possibly have. The problem with it is that it doesn't fit that one table per class convention. I'll come to you in just a second. It doesn't fit that one table per class convention, but I don't really think that's a big problem. We can figure that out. We're smart people. We can have a table that has all these columns, and we can figure out what columns map to what classes. That's a straightforward thing for us to do. Another problem, though, is that we have taken every subclass and we've taken every property in every subclass, and we've just kind of made columns for everything. And now, when I do this select star from this table, I'm getting properties for everything in every single row. It's going to be difficult for me to discriminate between the actual types of the things that each row should represent. I can figure it out. I can look through and I can say it has this value and this value and this value, so it's probably of this type, but I have to have logic to be able to do that. A solution for that is we can use this idea of something called a discriminator column, where we add one more column to this, and the value that's in that column is effectively the name of the class that this thing is. So the subclass that this thing is now becomes part of that entry for that row in the database that we've got. The other problem that we have is tables just don't have an infinite number of columns. And if we've got, again, 100 different subclasses, that's a different problem entirely. But if we have 100 different subclasses with many, many, many properties across all of them, we're kind of going to have a problem with this. We don't have an infinite number of columns, and that ultimately means that we've got to specify all the columns when we create the tables. So that means that the table is going to get pretty big pretty quickly, because we have to have a column for every property in every single subclass of all of the subclasses that we've got here. It's also going to be kind of hard to have constraints in this system. If I have not null on something, and I've got that not null across different subclasses, I have to have not null for every entry in this table. And that means that if subclass A and subclass B have independent not null things, I may have to insert arbitrary data ? To just satisfy the not null constraint, or not have the not null constraint. And that doesn't really super work for us. It's harder to include these constraints. It's harder to say things like unique. It's harder to say things like I want to have relationships that are required between different subclasses of these things. We're also now going to have lots of wasted space on unused columns, but I'm going to say that this is a trivial problem because we have terabyte-sized disks, and we're talking about bytes per row at most. This is not an actual problem, but it feels like a problem when we're thinking about this in the large. Yeah, your question.
You talked about this concept of that we don't really have an infinite amount of columns, and that when we flatten, we need that. But you didn't really show us how it would look like when we flatten. Like, could you just give an example of tables and we try to flatten them to see how it looks like?
Sure. I mean,
can't really imagine it.
I'm going to go here. So this is our code sample from last term, and the place that I'm going to look here is in the domain model, and we've got these items. So these are the two items that implement this item interface. Cure all conditions and potion, they differ by one property, in that cure all conditions has no properties and potion has one property. That means if I want to make a table that represents this interface that's called item, I have to have at least 3 columns on this table. One of them is going to be the key. It's going to be a synthetic key because, I mean, this cure all conditions has no properties to have a natural key, and amount is absolutely not a natural key. This is something that's going to be common across all instances of this. So the item table that I have will have a synthetic key column. It's going to have an ID. It's going to have, at least in the sense of, I want to have this discriminator column. It's going to have a column that's of type varchar of string, and it's going to have values in that column that are cure all conditions, and it's going to have potion, and then other types of this implementation of an interface that I've got here. So whatever other kind of columns I've got. And then it's also going to have a column for amount. So even if I'm inserting into this table an instance of cure all conditions, that row must have an amount in it. And if I'm inserting something that's of type potion, it's going to have amount, but like this other one doesn't have any properties on it. This is taking that class structure and just squishing it down and taking all of the possible properties on all of these different implementations and just making columns for each of those. Hitting the limits of how many columns you can have in a database it's like, you've got bigger problems if you're hitting the number of columns in a database by flattening this hierarchy. One last thing I'm going to say is somebody posted this on the course discussion forum in Off Topic, and I thought this was really nice. I'll let you read this block quote. And this is an awful solution. This is a really, really bad solution. But like, the max column limit on databases is bigger than Excel. Actually, no, I'm sorry. At least in this article, it's smaller than Excel, but they're using Microsoft SQL Server, I think, in this article. And it's who knows how old that they're doing it. But even though here, so it was 1024, it appears to be 4096. If you have that many columns, that means you've got at least 4,000 classes that are subclasses of this thing, and that's unrealistic to actually happen. So I hope that gives you a visual picture in your head, at least, of what this table structure might look like if we were to take these classes and squish them down into one table. Yeah.
Just to make sure I understand it clearly, like if we assume that we have multiple kinds of Pokemon and each one of them has a trainer, so that when we squish them, we will have a trainer column for all of them, so we don't really need to query for multiple tables.
Yeah, right. Okay, so this table then should have 4 columns. It will have the synthetic ID that is the synthetic key that's the identifier. It will have the discriminator column. It will have a column for amount, and it will have a column for the trainer that owns this item. So I can do select star from item where trainer name equals whatever trainer I'm trying to look up all the items for. And I'm going to get all of the rows that have those things. Then I'm going to have to go through each row and like determine which type I should initialize based on the discriminator column. But it's reversible. I can take that table structure and kind of go back to the corresponding instances that we've got. Yeah.
I just wonder if there is like a property for a class that we would like to store in a database, but there is no way around it, like no way to kind of simulate that property in the database. Or like around anything, we can have something that works for it.
So your question is about wanting to know, I guess, if there's different kind of types that we could have that we can't represent in a database?
That we really can't, there is no way to represent that in a database, even if we want.
In terms of data, the lowest common denominator is basically binary data, and you can represent binary data as a type in a database. If there's concepts in your OO language that are like type system stuff, maybe, but I'm not sure I would have a good example of what that might look like. So like if you have files that are part of your domain model, there is a property on your class that is of type file, you could possibly put that in the database as a binary blob. And the other option is to have a path to a location on the file system. So storing a reference to where this file is located and that's kind of up to you then to determine how to reload those things. I'm not sure that that answers your question, but it answers part of your question, I think. Yeah. This is a pretty funny read, by the way, if you take the time to read it. I enjoyed it. Okay, so we've got these two options. Which one is best? And so I'll ask you right now, just based on what we've talked about, which one do you think is best? By showing a finger of one, option one is let's have a table per subclass, and two is just flatten everything. And so I'm going to ask you to do this on the beat after three. So I'm going to do 1, 2, 3, and then everybody will do 1 or 2. Okay, ready? Are we ready? Okay, so 1, 2, 3. Okay, good. I don't know. I don't really have a best option here. I'm glad that you have kind of like made that decision in your head, but I don't really think there is a best option here. We can compare the two concepts, and we can kind of like try to use this in a decision-making process about which one is best, but I don't really have this. I really hope I'm distracting you with this GIF that's moving in the background of all these slides. The one table per subclass is going to definitely lead to smaller tables. Like, we're only going to have as many columns as we need for properties on those tables. For cure-all conditions here, we're going to have one column, maybe 2 columns. We're going to have one for that synthetic ID and one for the trainer that owns this item, and that's it. We're not going to have lots of extra columns for this thing. We're going to have one class per table, and this is going to be like the same convention that we've got for all the other tables that we're working with. And we're going to be able to have realistic constraints. We're going to be able to say not null on these columns. We're going to be able to say that this is a foreign key that references this other thing on arbitrary values, and we can say that you have to have this specific value on this table. It is tedious to load all subclasses, but once again, if you have so many different kinds of subclasses that it's tedious to load them, you've got different kinds of problems here, and you maybe need to rethink the structure that you've got to represent all these different ideas. If we take this flattening the hierarchy idea, it's now straightforward to load all subclasses because we can just select star from this table and get everything that we would possibly have here. But we've got one really big table. Adding new types to our subclasses now means that we have to change that table. And that's possible to do. We don't have to drop it and reload it in the way that I've done in class. We can alter an existing table, but it's now going to be challenging to make changes to the structure that we've got here. It's going to be a lot harder to enforce constraints. Putting not null in a column means that it applies to all of the types that we have. And I'm going to have something in that column for every one of those things. And we're going to waste space. But I am again going to say that that doesn't actually matter. Like, this is not a realistic problem when you have, gosh, I don't know what the biggest hard drive is right now, but I'm thinking like 24 terabytes at least for hard drive sizes. Hard drives are very big. You can buy a petabyte of disks that just go in a single rack now. You have a lot of disk space available to you. So wasting a few bytes per column is really not, per row in a table is really not a relevant problem. All right. Are there any questions about that before we proceed to thinking about phase 2 here?
How are we gonna enforce constraints for putting like all in one table?
We can't. That's kind of the answer to that question. The way that we can enforce constraints are the constraints that apply to all types. Yeah. So in the case of this item table here, where we have 4 columns, we've got that synthetic ID, we've got the discriminator column, we've got the amount for the potion, and then we've got the reference to the trainer. Everything should have a trainer. And so we're going to be able to say there's a foreign key and it should not be null on this column. But for potion, this really ought to be not null in my database. But with cure-all conditions, I don't really want to have that be not null. Like, I want to just leave it null. I don't need to have a value there. The options that we kind of have for this are, we can just put arbitrary values like -1 or 0, so things that are invalid, to kind of say this is a sentinel. Cure-all conditions doesn't have a value, but I got to put something here, so I'm going to put a sentinel value there. The other option is just accept that sometimes it's going to be null and then have to enforce it when you're loading things back or writing things out. So as you are doing select star from item and you find that you've got a potion row, make sure that this is a positive non-zero value, because any other kind of potion is an invalid potion to have. Yeah. Yeah.
Would it be potion, cure-all, or cure-all condition, and then you would have every possible property, and if it doesn't have it, then that will have to be some arbitrary value?
So if we're going to call this our item table, so I'm going to make this sheet called item to represent the table that we have for items. I'm going to say that we're going to have a column here that is called ID. This is our synthetic key. We're going to have a column here that's called trainer. This is going to be the trainer that the item belongs to. We're going to have a column here that's called type. This is going to be our discriminator column for the kind of class that that the row actually represents. We're going to have an amount for potion, and gosh, what's another item? What's the name of the item that cures PP, that restores PP? Is it just restore? I don't know. I'm just going to put this in here, and we can all agree that there is some item that you can buy that will restore PP, but just on a certain move, and we'll just say that it can only be a certain amount. So there's different amounts of things that you can have. So if I have one, I've got Franklin here, it refers to me as a trainer. I'm going to say that this is cure all conditions for the type of this thing, and the amount and the PP amount here are going to be, for both of these, null. There is no value in this table for those columns. I'm going to have another one. It's also, for me, I've got a potion here, and it's going to have an amount of 10. It restores 10 HP. The PP amount here is null. I'm going to have another item in here. This one belongs to Walter. This one is going to be Ether. I think that's maybe what it's called, that restores PP. The amount here is going to be null, and it's going to have a value of 10 for how much it's going to restore to each of those moves. So my table is going to look like this, and it's going to have columns for like every property that I have, if there are extra properties on any of the subclass types that I've got for this hierarchy. Then I'm able to write queries like select star from item, which is this table. And when we get back values from this, we're getting back all of the rows. And this for us is a matrix. We're going to iterate over each of the rows in the matrix. And we're going to have to decode, like, what is this discriminator column that we have for type? That's going to tell us which constructor to call and which values we should then try to get out of the corresponding rest of the row for this thing. Does that help better visualize the structure for both of you? Yeah, okay, awesome.
Not like an interface, so you have the set amount of value, so it won't have empty columns, because right now it's name.
Yeah. So the trainer table itself, we're not going to have this issue because we don't have subclasses of trainer. There aren't different kinds of trainer that will have different possible values. All trainers have the same values, and they all have the same constraints and references and that sort of thing. Yeah. Okay. And I think there was another question here. Yeah.
There be a way to column nullable based on the discriminator?
So the question is, can you have a column that's nullable or not nullable based on the discriminator? If there is, I'm not aware of it, and it would be really far outside the scope of this course to have those kind of complex constraints. I would say that if you do this approach, you just don't have those nullable constraints on things, and then enforce it when you're loading them back up. Enforce it when you're writing them out, and enforce it when you're loading them back up into your data model instances, your domain model instances. Yeah. Any other questions? All right, awesome. Okay, so I'm going to close Java here. And what I want to do is take a quick look at our phase 2 stuff. So what I'm asking you to do overall for phase 2, and take a brief look at some of the tasks that I'm asking you to do for each of the different project streams. I was trying to look up pictures of these cookies, imperial cookies. Like, this also seems to be a Winnipeg or Manitoba thing. Like, there are empire cookies in Scotland, but I've never heard of empire cookies before. But these are cookies that have jam. It's just like 2 sugar cookies on top of each other with jam in the middle of them, and I love them. They're great. If you see these in a store, please buy them. It's worth your time to take a look at that, to taste it, to have one of these cookies. So, what we're going to be doing for the design portion of phase 2 is I want you to start taking the domain model class diagrams that you've got, and I want you to start adding data modeling concepts to it. So kind of like what we've done in class, I want you to take your domain models and I want you to add things like cardinality to it. I want you to do the conventions that we've got for bidirectional relationships. And I want you to do things like adding nullness constraints or not nullness constraints and uniqueness constraints on the data model that you're building up here. I'm going to scroll down here to version control. So I'm still recommending that you use version control for this. I did add something to this command. So if you are looking to rerun this command, I added this prefix option. This makes it so that when you archive your repository, it puts the archive inside of a folder in the zip folder, because when I've been assessing work, I'm expanding these and they just they dump stuff all over the folder that I'm currently in. So having this prefix puts it inside of a folder inside the zip file, but otherwise it's the same. The 3 things that I'm looking for you to submit for phase 2, I do want you to just submit your entire project structure now. So these should just be part of your project going forward. You are welcome to submit these separately, I guess, if you want, just as 3 files, but I would expect that they just go along with the project structure that you've got now. I'm looking for you to submit your domain model and class diagram where it's got the changes that include the data modeling concepts. There are going to be some new tasks. I'd like you to submit that flows.md file to represent the flows of interaction for those new tasks. And I also want you to submit your create table statements that correspond to the data model that you've got. For the domain model, it's the same sort of thing. I want you to submit a file that has markdown and mermaid representation of your class diagram. But now we're including things like not null constraints here, or nullness constraints. So this one is the unique one. So this is the unique constraint. I've added that synthetic ID on this class. I've got question marks on other classes to indicate that we've got possibly null values. And I'm also adding the cardinality here. So I'm representing on each side of this what whether it's a one to many relationship. Yeah.
So like, are we supposed to reflect the inverted like classes in our implementation?
You should have bidirectional representations of that, at least in the class diagram here that I'm asking you to submit.
Yeah, but we don't really need to change that. It's not necessary.
You don't necessarily need to change your implementation. We're not looking at your implementation for this part of the phase 2 stuff. Yeah. When you're doing the relationships between these classes, you can do it either as 2 separate statements here. So like you can say account to animal and then animal to account as 2 separate things, or you can merge that all together into one single line like this, and it will put the different types of composite or aggregate symbols on either side of that line. I would also like you to include just a plain English summary of like the kinds of changes that you've made since phase 1, either in response to feedback that you've received or just as you've actually implemented it. I needed to add this other thing, and then also what you're making changes to for phase 2. For our flow diagrams, what I want you to do for this is submit flow diagrams, but what I want you to do is very clearly indicate which ones are for phase 2. We're not going to bother looking at the ones for phase 1. We'll just assume that they still work the same way that they did before. Yeah. For the changes here, I want you to submit that in, for the changes to the class diagram in the domain model, I want that to be in the domain.md file, yeah. The README itself at this point should stay pretty static. It should say, look in this file for my domain model, look in this file for my flows of interaction. And this is how to run my software. Same thing, if you're making any changes to your flow diagrams from phase one, just tell us what you've changed so that we have an idea of the kinds of things that you've made. The last thing that I want you to submit is your DDL, your data definition language. These are your create table statements. This should just be a file that's called createtables.sql, kind of like what we've done in class. This should represent the table structures that you're going to use that refer back to the class diagrams that you've got. I'm not going to dwell too much on the rubrics here. I'll let you read these on your own. But the thing that I do want to point out here is that for the flow diagrams, this is the nth time that you're being assessed on flow diagrams. So for flow diagrams, there is no mastery requirement here. It's just you get credit for doing the work, but I'm not really going to be worried too much about perfection of what you're doing or a minimum level of competence here. So for each of the different project for each of the different project streams, I've put together a document that kind of describes what I'm looking for you to do for this. First, we're going to move a little bit away from this MVP idea. With phase one, the big goal was to get you comfortable with your environment. It was to get you comfortable using this new tech, using the command line if you're using the command line, using TypeScript, using your web browser and the tools that are attached to your web browser. But as we proceed into phase two, we're going to start adding some quality of life improvements. So to actually start making this better than it was before, more usable, in the case of a game, maybe a little bit more fun than like blindly just clicking and being able to buy infinite upgrades. The other things we're going to be adding here are persistence. This is for both project streams, and the other thing we will add for both project streams is that there will be some concept of user accounts attached to the projects that you're working on. For the clicker game, what I want you to add to this is buildings. I want you to be able to add buildings, and buildings are the things that will actually do auto-clicking. So upgrades, if we want to be pedantic about clicker games here, upgrades increase your clicking power and buildings will do auto-clicking for you. I want you to be able to buy buildings that do auto-clicking, and I do want you to have a couple of different kinds of buildings that you have in your game. And I want you to be able to have user accounts. So I want you to be able to make a new account and then sign into that account. And every player that you have in your system should have their own game state information. I don't want you to have servers outside of what we've got. Like, this is all still going to be a local first application. We're not doing any kind of proper web authentication here. This is just going to be fully contained within the system that you've got. And the other things that I want you to include here are just some small quality of life improvements, like the things that you have that you're buying should not be free. They should cost something. And I do want to see some meaningful names for the kinds of upgrades and stuff that you're applying here. There are some design choices that I want you to make independently. So in terms of the class structure that you have for buildings and upgrades, how are you going to represent those things? In terms of the relationship that buildings and upgrades explicitly have themselves. And then I'm not going to talk about this in class because it's really specific to this project stream, but I've given you documentation that you can find out about. The tool that you're going to need to use for doing auto-clicking is called setInterval. This is a method or function that you can call kind of globally, and it will just set up a timer. It will cause this thing to happen every n units of time. I've given you a link to where you can find information about how to do that. But the question that I leave for you as a design choice is, where does this actually go? Who is responsible for having this set interval in it? Is it part of the view? Is it part of the controller? Or is it part of the domain model itself? For the point of sale system, what we're doing here is I want you to do some similar stuff. So we're going to have user accounts. These are going to represent the cashiers that we have in our system. And the thing I'm asking for you to add here are coupons. Coupons are going to be things that apply to receipts, and they're going to make changes to the total costs that you have of the receipt that's being produced by the system. So I want you to be able to have user accounts for cashiers. And the cashiers then should have receipts. That's what we want to be able to represent here, is that cashiers have receipts. And then I want you to be able to choose coupons. So coupons should do things like applying discounts 20% off your whole purchase, or you get to buy one, get one free. So one of these items will cost 0 if you've already bought one of those items. For both of them, I want to point this out. We're not strictly requiring MVP anymore, but you still shouldn't build things that aren't asked for. Or user accounts, I really just want to be able to make a user account and then sign in with it. I don't want to manage it. I don't want to be able to make changes to my names. I don't want to be able to delete user accounts. I just want to make a user account and sign with it. That's all I'm asking you to do. Please do not make complex user management systems. That's not something that's important or relevant for this. Focus on what's being asked for what you're doing. For the quality of life improvements, I want you to have timestamps on your receipts. So we should have some idea of when this transaction happened. Products and coupons, similar to upgrades and buildings, they should have meaningful names and descriptions. Many of you already have meaningful names and descriptions for your products, but I do also want the same sort of thing for the coupons that you've got. And I want you to add one more kind of product. If you've got 2 right now, you should have 2 right now. I want you to have one more kind of product. And the thing that I'm looking for you to do here is, if you're measuring things in terms of physical units, like I'm buying 5 shirts, I want the new thing that you're adding to be a different kind of unit. So like measured based on volume or size, as opposed to just distinct things. For design choices that I want you to make independently, I'm looking for you to think again about the structure and the relationship between coupons and products. So like, how are you going to represent these different ideas? And then I want you to also independently be able to kind of figure out how to do the timestamp stuff in TypeScript and JavaScript. I've given you some links to documentation and articles about timestamps and time and dates in JavaScript and TypeScript. And I've also given you a reference to the PostgreSQL. This is the database that PGLite is using internally. This is some documentation describing how you can represent times as column types in your database management system. All right. This is our last time together before the break. And so I wanted to give you a chance to ask some questions about the project, if you have any questions. So we'll hold this here. Some of you have already asked questions. Great. If you have any verbal questions, I'm also happy to answer those. Yeah.
Can we use external framework for CSS, like Tailwind, Constructify?
So the question is, can you use external frameworks? Sure. One thing I'll point at here for acceptable uses of AI as well, CSS, that's fine. Don't let it get in your way of succeeding at the tasks that you're being asked to do. For the record, the ones that I've graded so far, they look great. Some of them do look like absolute garbage, and in both cases, they've got the same mark. So like, please don't let it get in your way of trying to make this look super nice. If you want to use AI to generate CSS, awesome. If you want to use a framework to use CSS, fine. Just don't let it get in your way of actually accomplishing the tasks that we're trying to do. Here's my first question for you. I'll give you, I don't know, 20 seconds to answer this question. I'll give you 5 more seconds. There's lots of people kind of joining up here. This is exactly the answer I was expecting to see. So awesome. That's really great. Yeah, I don't know. This is some bullshit question. There's no meaning to this question. Here's the thing that I actually want to give you. Do you have any questions about the project? Do you have any questions about the course? Do you have any questions that are burning a hole in your head that you need answered right now? I can't get it to you before the reading week break. I unfortunately don't think I can give that to you in the next 48 hours, but my next task after grading your term tests over the break is to start writing this. So you can expect to see it showing up over the reading week break. Yeah. Yeah.
If we have a property that's the same across all classes, like a static integer, for example, is that, I assume that's not necessarily stored in the database because when we bring our classes back, construct the instances, it's automatic there.
So the question is about static properties on classes. So they're all the same for every single class instance. It would be reasonable for you to change that to be a property on the class, like an instance variable as opposed to a static variable. And the thing that I'll point at for that is actually this, where I've got an amount here. All potions will always have the same value of 10, but they might have, it might be reasonable for me to represent these as different values. So at runtime, I want to make a potion that has 50 restore value instead of 10. So for migrating away from just keeping things in memory and starting to do persistence, it would be reasonable for you to put these into instance variables instead and still just fix the value, so have it hard-coded. The other option is what you're saying, just don't put it as a column in the table. Leave it as a static variable and that's it for forever. For things like cost, so both project streams now should have some concept of cost in them. Cost is a value that shouldn't be a static variable. That's something that will change over time, and I would want different records in my database to have different costs, even if they all happen to be the same for now. Inflation, friends, it's a real problem, yeah. As we go forward, the cost of things will change. It's going to cost more cookies to buy this upgrade. It's going to cost more dollars to buy this banana. Yeah. Does that answer your question? Okay. And there was a question behind you? Okay. Should we memorize SQL? Gosh, probably not, at least not for now. SQL is something that, so based on what you saw in the term tests, I mean, I'm expecting you to have some understanding of it. I did expect a little more of you about SQL than I did with HTML. There was no expectation that you understood what the HTML was doing on that test question, but you had to have some idea of what like the constraints were about the SQL that we were doing. So to seriously answer your question, memorizing SQL, probably not. In the same way that I wouldn't expect you to memorize TypeScript or JavaScript. I'm not going to be too strict on syntax if I'm asking you questions about it, but you should have some clear ideas of what the language is trying to do. Does relationship between two classes in a data model always have to be bidirectional? So if you have a collection between two classes, I do want you to have this convention that they should be bidirectional relationships, yes. If you have a collection of one thing containing the other thing, I want you to model it that way, again, so that when we get to making tables, we know that this is the one side of that relationship. If we have a one-to-one relationship, then you actually should just model that because you have a one-to-one relationship between these different classes. If you have a many-to-many relationship, and I really can't think of a situation where you would have a many-to-many relationship in the projects that you've got right now, you still have to have that relationship between those things. If you take your actual domain model and implement it, I'm not necessarily looking for you to have that bidirectional relationship actually physically encoded in your domain model, but it's something that's in the class diagram because I want to see that you've got both representations of the SQL tables that you're going to create and the classes that you're going to set up. I hope that answers this question adequately. Do we need to add images for the POS or can we just have writing? Yes. Again, it can look like absolute garbage. The images are very optional. You don't have to have images if you don't want to. Same with CSS. No. Should I follow Cookie Clicker's example to start my cookie empire? After you're done this course, yes, please, all summer, start a cookie empire. Build empire cookies. Are you cooked? I mean, I don't think so. So I think I've answered this on the forum, and I might have answered this verbally in class. For the tests, like the average on the tests, I'm looking for the average across the tests. It's not that you have to pass every test. It's going to be the average across the tests. So if you didn't do too well on this one, you may be able to recover as you go forward. I answered that one already. I answered that one already. If instead of using the ID from the database, can I use my ID in my domain model class? I'm not actually sure I understand this question. If the person is in the room and they're willing to clarify what they mean. Can they clarify what you mean by that? Okay, I'm really sorry. I'm not 100% sure I understand what this question is asking. That maybe that was somebody texting to say, like, this is what I mean. Do I teach 2280? No, I don't teach 2280, sorry. The last time I thought about assembly language programming was about, gosh, that would have been 2004. That's the last time I thought about doing assembly language programming. And when I did assembly language programming in that course, it was 74-222. So comp used to be course department number 74. And we only had 3 digits in our course numbers. So it was 074.222. And this is our assembly language programming course. And I learned actual architectures. We learned 68K, which is 68,000, which is the processor architecture that's used on like old Mac computers. And we learned Spark, which is on Sun computers, which is a company that you may or may not have ever heard of. Have you heard of Sun before? Some of you. Sun made Java before Oracle bought Sun. Yeah. Do you have a question?
So yeah, is assembly stuff related to operating systems?
Can you repeat the question, please?
Is the like assembly stuff related to operating systems?
Is it related to operating systems? At a certain point, yes. You have to do some assembly stuff in operating systems because when you build an operating system, normally you're going to build it in such a way that you'll be able to compile it to run on different architectures. So like I'm running Linux and many of you are running Mac OS and many of you are running Windows. I think that captures everybody in this room. Linux is compiled for many different architectures. It will run on your M1 Mac as well as it does on my laptop. That's an Intel processor. Mac OS can run on Intel processors. Windows can run on ARM and Intel processors. There has to be some assembly language stuff as part of that, but mostly it's written in C or C++ as opposed to assembly language. But to get access to hardware level stuff, you do have to drop into assembly language to be able to do that. Fair enough. I can try to clarify what I mean by that before proceeding to the term test, but it was really just about, I don't really want you to have to worry about formatting HTML stuff. Just write stuff out with console.log. This is a fair question. If the item table had its own properties, we would just have another column on this table that would have item properties. So I'm not really sure what kind of item properties we might have on here, but also I'll just write item properties here. If there's specific properties that all things would have, then we could then say things like this column can't be null for everything because they all extend from the same superclass. If we have properties on that superclass, then this would be how we might do that. Depending on the structure of your class hierarchy, if your implementations don't have their own properties, then the only things that you'll have in this table are the things that are in the superclass. Can it be open book? I don't have a book to give you, so no, I'm sorry. I think I answered that. Oh, thank you. That's very nice. Sure. If there's an element on the web page that's added at the beginning and never removed, like a header, you can put it into index.html. That would be fine. I think that makes sense to include it there. Then I think that's it. All right, awesome. Okay. Then I have a question for you, and this is an actual question this time. As we are starting to think about persistence, we've got these 3 parts of our architecture. Who really should have the responsibility of implementing this persistence? Or at least be responsible for interacting with the database directly? I'll give you 5 seconds to answer this question. All right. Okay, good. Yeah, this is actually what I was expecting to see here. Our model really should be the thing that's responsible for interacting with the database that we've got in our system. All right, I'm going to close this. Thanks all for participating in that. Really quickly here, we've got underworld ovens now, and we've got 10 quadrillion cookies, so I'm going to do this for all of you. We will definitely not have enough cookies to buy the afternoon one. But our bingo research facility is starting to do some interesting stuff. Our grandmas have not turned scary yet. And as we're buying these research items, it's not asking us if we're really sure that we want to buy these research items. It will start to ask if we're really sure if we want to buy these research items, because our grandmas are going to start to get scary after a little while here. Here is our architecture. And at the beginning of the term, we were talking about the structure of this architecture. And at this point, I hope you have a pretty reasonable idea of what each of these different parts do and how they're connected to each other in terms of actual code. Like, I hope you can imagine some of these ideas in your head about what's going on internally. But the one thing that we haven't touched here is about persistence. So we said that this is what was going to happen in the model at the beginning of the term, but we didn't really do anything with it. And so what I want to do now is spend a little bit of time actually putting this stuff together in the context of the sample project that we've got. So our model is going to be what's responsible ultimately for interacting with some implementation of persistence in our MVC architecture. And a fair question is, how are we actually going to do that? And so I want to work on this together. If you want to follow along with me, I'm going to ask that you pull the repository that we're working on, because I made changes to this outside of class. The small changes that I've made are just to more closely align what we had in our class diagram with the actual implementation of the classes. So I've done things like adding a name to our trainer class, as opposed to just having it with a team of Pokemon. What I want to do is add some persistence that happens when a trainer gets created. And so what that means is that I want to be able to go to this page, and I want to be able to ask the question, is there a trainer? If there isn't a trainer in the database, I want to make a trainer in the database. If there is a trainer in the database, then I want to show that trainer's details. So I want to implement something that's going to give me the ability to interact with the database in a couple of different ways. The first thing that we're going to do here is I want to establish a connection to the database. We're going to do that in main.ts ultimately, and we're going to get that to load the DDL that we're working with. So I want to have this as be part of my entry point. I want to fix the REPL that we've got. We created a separate file to represent this thing, but I want to move this into index.html. The reason for this is that as I was starting to work with this, I was finding that having two tabs open was causing inconsistencies between the databases that we had in the two tabs. And so I just want to merge it all together into one single page. And then I want to write some code to interact with that database. I'm going to give you a very clear note that the code we're writing today is not excellent code. We're just trying to get this task done right now. When we come back after the break, we're going to address some of the issues that we have with the code that we're introducing here. But please keep in mind that it is kind of intentionally not super well designed in terms of like making sure that responsibilities are separated. So if you do want to follow along with me, like I said, please pull the sample project because I'm going to be starting from a point that's a little bit different than where we left off last week. So I'm going to pop over here to my terminal. This is where I've got those changes that we're going to start from. And the very first thing that I want to do is I kind of want to set up this database object that's going to be effectively a singleton. So I'm going to add a new file to my model folder. My model is ultimately what's going to be responsible for doing persistence interaction. It's going to have the responsibility of interacting with my database. So for me, this is a logical place to put this singleton that represents my database. I'm going to add a new file here, and the file I'm going to add is called connection.ts. And what I want to put inside this file is really, I want to have a function that's going to give me access to a variable that's been initialized with that connection. So it's going to look a lot like what we did with the REPL when we set that up. So making an instance of this pglite thing so that we can start to interact with it. So I'm going to import pglite. This catches me up lots. It's uppercase P, uppercase L, uppercase P, uppercase G, and then lowercase lite. from, and then what we're importing that from is electric SQL PG Lite. Is this big enough at the back for you? Okay. Yes. Okay, awesome. Thank you. Then I'm going to make an instance of this database. So I'm going to say const pglite db. And I'm going to say that this is equal to, and I'm going to introduce a new word to us. The new word I'm introducing to us is await. I'm going to ask you for right now just to blindly accept this word. I'm typing it in. I want you to also type it in if you're following along with me. But this word is something that we'll touch in a little bit. For now, just blindly accept that this is something that we're doing. I'm also going to make an instance of this slightly differently than we did before. I'm going to say pglite.create. And I'm going to pass that same thing that I did before. So idb:// 2452 imon. So idb:// 2452 imon says to use indexdb as the backing storage for pglite. And really, this is permanent storage. This is permanent storage for us in the web browser. I want to be able to expose this thing that I've created to other files. I want them to be able to get access to it. And so I'm going to export a default function. I'm going to call this db. I don't want it to be too big because I really just want, I'm going to be using this in lots of different places in terms of the name of the function. And all I'm going to do here is return pglitedb. This is functionally the same thing as having a class with a static variable and a singleton. I don't have a class. I'm just exporting this function, and it's giving access to this variable that I've declared only inside this file. Nobody else can see this variable inside this file because I haven't exported it anywhere else. This is going to give me the ability to make changes to the thing that I'm returning ultimately, but this is functionally the same as singleton pattern. I'm going to use this to get an instance of this thing. I'm going to write this out. I'm going to save it. And then what I want to start to do is I'm going to open up my, I'm going to start to open up main.ts. And what I want to do in main.ts is the same thing that we did with that REPL. I want to give this the responsibility of setting up the DDL. I want it to be responsible for creating tables. So just like we did with the REPL, I'm going to say import DDL from. This is going to be a relative path to this create tables file, and I want to import that as raw. So I want to import it so that it is a string. And then what I'm going to say is I want to import the database from model connection.ts. And then just before I initialize my trainer controller, I'm going to do the same thing that we did before, db.exec DDL. I'm going to load the tables into the database. So every time I open this app, my expectation now is that we're going to try to create those tables. We put that if not exist, so we're not going to be constantly loading those tables in if they already exist. But this is kind of the responsibility of main.ts for me because it's responsible for doing the initial setup stuff, coordinating the instances of the app that we, the instances of the classes and stuff that we have, setting up any dependencies that are necessary here. I'm going to save that. And what I want to do next is I'm actually going to open up, index.html. And I want to put the REPL inside of this. Like I said, when I was working with this outside and having two different tabs open, while we were referring to the same database and they could talk to each other, it wound up kind of like messing up state. Some things would happen in one place and they wouldn't happen in the other place. So I just want to merge this functionality together. So I'm going to open up both index.html and REPL.html, and I'm going to copy stuff from REPL.html just directly into main.html. So I'm copying all the stuff that I put in the body of this REPL file, and I'm going to move it into index.html. I'm just going to paste it below loading my main.ts. I'm going to change this stuff. I don't need this to do the import, and I don't need to create the instance of this database, and I don't need to do the exec here anymore because main.ts is doing all of this for me. So I'm actually just going to delete all of those lines. And what I'm going to do instead here is I'm going to import db from source model connection.ts. And I'm going to change this REPL.pg to be db. I wanted to have that connection to the database that we've got. The last thing that I want to do to my index.html is I don't want this REPL to show up every time I start the page. And so I'm going to use an HTML element here that's called details. The details element, it's something that will show up as like an arrow that you can click on to expand and hide something. We just kind of get this functionality for free from this element type. And I'm going to put inside of my details a summary. This is the text that shows up that I can click on. And I'm going to write show hide REPL. I'm going to start my server here. And I'm going to go back to my web browser. And if you're following along with me, we've got now the show hide REPL. This is now the actual REPL that we had before, showing up at the top of the page. But now we don't have to have two different tabs open to be able to interact with this thing. And what I'm expecting you to see here is either create trainer, or on your page, you might see hi something showing up already. If you're following along with the most recently pulled version of this.
So right now we create a table only once when we run command to npx suite, right?
Every time we open this page, it's going to do the create table, but if not exists. So it's not going to try to rerun those statements if the tables already exist. Okay. I'm going to go back to my code. And what I want to open here now is I want to open up the trainer controller. As I said, this is a little bit different than where we left off last time. I've made some changes to this. But the thing that I really want to be able to do with the trainer controller is that right now we are unconditionally creating this create trainer view. It's popping up and it's asking us if we want to type in the name for a trainer that we want to load. What I really want to do with this is I want to ask, are there any trainers in the database right now? I want to be able to ask that question of something. Are there trainers in the database? If there are no trainers in the database, then I want to be able to add a trainer to the database. So make an instance of this create trainer view. If there are trainers in the database, then I want to make an instance of trainer view. We already did this, so I want to be able to get that trainer, and I want to be able to put that trainer into the view to show up on the page. So I'm going to have to start making an instance. I'm going to have to start writing some code, that is going to give me the ability to ask that question. The place that we're going to want to have that question be able to be asked is in the trainer class itself. So I'm going to open up the trainer class. And what I want to do with the trainer class here is I'm going to start writing a class method. I'm going to write a static method that's going to give me the ability to get access to all the trainers that are currently in the database. So I'm going to start typing this in. I'm going to ask you again to blindly accept some words that I'm typing in. And we will talk about what these words mean, but for now, just accept that I'm typing these in. So static is something that you're already familiar with. Async is a word that you are probably not familiar with. Maybe, maybe not. We're going to say get all trainers. So this method is going to be responsible for retrieving all trainers from the database. And what this method is going to return is, again, blindly accept this, please. It's going to return a promise. And what the promise will contain is an array of trainers. We'll come back to that in a moment. I'm going to make an array of trainers. These are the trainers that I will eventually return. So we're going to start with an empty array. We're going to populate the array based on values that we're getting back from the database. I'm then going to say let results equal. And here is where I want to start interacting with the database. I'm going to say let results equal. Please accept this. Please just blindly type this word in, await. I want to await. We're going to use that reference to the database. So I'm going to have to import this. I'm going to go to the top and come back down in a moment. And this is in this directory. I want to import db from connection.ts. I want to await, and what I want to call on my database object is this query function or query method. Query is a method that we're invoking on that pglite class. So we made an instance of that, and we're returning that from the db thing. I want to be able to run this query. The arguments that query takes that we're going to give to it is the actual query that we want to write. And so I want to be able to get trainers. I want to be able to get all trainers from the database. And so I'll say here, select star from trainer. The table structure that we had for this, is that trainers have a name, a favorite mart, and a foreign key. I want to get, at least for now, I want to get everything from that. I'm going to make a small change to this. I don't want to get everything. I just want to get the name. That's the only thing that I want to get from this. I want to select name from trainer. What I'm going to be able to do here, and what I want to do with this, now this is a TypeScript thing, is I want to describe to TypeScript, the compiler, what the shape of the results are. So the results that we have here are that we're asking from the database, I'd like you to give me all the values that are in the name column of the trainer table. So the thing that we're going to get back from this, so I'm going to put this in angle brackets here, is going to be an object that has entries that are called name and their type is string. This is kind of unusual looking syntax, but this is really just saying that for each of the rows that I have in the database, I'm going to get a JSON object back. It will have a single key. The key is going to be called name, and the value that you get from that is it's a string that represents this thing. Once we've got this results, we're asking pglite to give us some data back from the database. Once we've got the results here, we're going to want to do something with the results to transform those back we need to transform those rows into instances of trainer. I have to take the names that have been returned to me and create instances of trainer so that I can put them in the array that I'm ultimately going to be returning here. So I'm going to do this. I'm going to say results.forEach. The results that I get back are a collection that I can iterate over. I'm going to call each of the things that I'm iterating here over a row. I'm going to say results.rows.forEach. So now you can see that we've got this, this type annotation that we've got here. This has a name in it. Each row has a name, and it's of type string. And for each of the things that I get back in this, I want to add a new trainer. And then at the very end, what I want to do in this method is return all trainers. Okay. We've got 3 minutes left. We can't finish this. We can't finish this, but let's illuminate some of the stuff that's going on. I'm going to ask you to ask me after class, okay? I want to illuminate some of what's going on with these words that I've asked you to blindly accept here. JavaScript is a single-threaded programming language. Threaded is maybe a word you haven't heard before. I'm going to introduce another word to you right now, concurrency. Concurrency, I'm just going to introduce 15 different new words in the next 4 minutes, not even 1.5 minutes. And then you can all go away baffled for your reading week break and then come back and we'll have a, okay. Concurrency is this idea that two things are happening at the same time. I am typing stuff and speaking at the same time. Two things are happening at the same time. Computers long ago had one processor in them, exactly one processor. But they could still make it seem like many things were happening at the same time. Imagine, 16-year-old Franklin sitting at my desk in my room with my Windows 98 computer, and I'm listening to Winamp and also talking to people with my instant messaging software. I can do those things at the same time, even though I only had one CPU in my system. Because my operating system effectively was able to take those different things and switch back and forth between them fast enough that it seemed like, from my perspective, many things were happening at the same time. JavaScript is a programming language where you have one thread of execution. When we went through at the beginning of the term, as we were starting to do this MVC implementation, and I put numbers, like number 1, this is what's happening. Number 2, this is what's happening. Number 3, this is what's happening. I really meant that. Every step we were going through was this linear path going from this one spot to the next spot. JavaScript is a single-threaded programming language, but sometimes you want to do stuff that's going to take a while. Stuff that takes a while is things like, I want to be able to ask for rows from a database. I want to be able to get rows back from my database. And for me to do that, it's actually going to take a while. And if I were to stop there and get rows from my database, the entire user interface would just stop working. I wouldn't be able to click buttons. I wouldn't be able to interact with the page at all. I would just be stuck. And so JavaScript has this concept of tasks that can kind of happen in the background. When I say db.query and await, what I'm ultimately saying is, I want you to start doing this, but I'm actually going to keep going. I want other stuff to happen. When I call getAllTrainers here and I say that this is async, what I'm saying is, I'm going to call this method, and then I'm just going to keep going. Something's going to happen inside of getAllTrainers. Those are going to happen at the same time. It's not literally at the same time. JavaScript as a language is kind of rapidly switching back and forth between these tasks and doing these things. But this ultimately says when I call getAllTrainers in trainer controller, trainers.getAllTrainers will still just do stuff, but it's going to return immediately to the controller. And the controller will then start continuing to build up the UI for this application. Within this method, await says, I don't want you to proceed within this method to this point until after this is done. You need to get back from the database something so that you can actually iterate over the list of results that you have here. When we come back from the break, we will finish building this up. But otherwise, I hope that you all have an excellent reading week break. And I will see you all in a couple of weeks.